Okay, the second form of our first order differential equation, we call it homogeneous equation. We define that the first order differential equation, which is called homogeneous equation, when you arrange the equation itself in the terms of dy by dx, it's got to be equal to the function of y over x. When you write it down, you arrange the equation if it can be written in the form of y over x. That equation we call homogeneous equation. For example, we have if this equation if this sorry if this equation no if this a homogeneous equation, sorry if this equation is a homogeneous equation, I said that if we define that this equation is a homogeneous equation or not, we got to write down dy by dx. If it is in the function of y over x, then we call homogeneous equation, right? So the way that we do is just rearrange the equation. We would get x dy is equal to minus x minus y dx, or y minus x dx. So our dy by dx is equal to y minus x divided by x, which is y over x minus 1. This one is a function of y over x, right? Because for one, it seems like this one is just like to have y over x to the power 0, right? So this is a homogeneous equation. This equation is a homogeneous equation because dy by dx is a function of y over x, like that. So the way to define whether it is a homogeneous equation, you've got to rearrange the equation itself. If you can make it in terms of dy by dx is the function of y over x, then that means it's not a homogeneous equation. Or let me give you another example. If I have dy by dx is equal to 2x plus y plus p plus 3, whether this equation is homogeneous. Equation. You've got to arrange it again. Find that dy by dx is equal to, if I take x out, is this a homogeneous equation? This one is not a function of y over x. We have y over x there. But this one is not y over x, and this one is not y over x. So it's not a function of y over x. So I would say that this equation is not a homogeneous equation. If I have this, divide by the x is, I'm sorry, if I have y plus square root x squared plus y squared dx minus x dy is equal to 0. The question is that whether this equation is a homogeneous equation. The way that we do it is rearrange the equation in such a way that dy by dx is a function of y over x, so you would get equal to y plus square root x squared plus y squared dx. So our dy by dx is equal to y over x plus square root x squared plus y squared divided by x. So with this one, you do it again, arrange it again. Dy by dx is equal to y over x plus x is equal to square root x squared, right? This x is equal to square root x squared, right? So then I would say equal to plus square root x squared plus y squared divided by x squared. Because I try to arrange it in such a way that whether it is a function of y over x, so if I could try to do this, try to arrange it in that way, okay? So this one I would get x squared divided by x squared plus y squared divided by x squared, which is equal to y over x plus square root x squared over x squared is equal to 1 plus y over x squared. It is a function of y over x. So this equation is a homogeneous equation. Still the same question that whether this differential equation is a homogeneous equation. You get to write down in the term of dy by dx, you would get dy by dx is equal to x squared times y divided by 1. Oh, this is x to the power 3 plus x to the power 3. Okay. With this one, you would get x squared divided by 1 over 1 plus x to the power 3 plus, I'm sorry, you would get x squared divided by 1 plus x to the power 3 divided by 1. So it's not a function of y over x. If it is a function of y over x, this term you would have x divided by y to the power 3 divided by 1 plus x to the power 3 by y over 3. But this one, It's not, because this one you have x squared, and this one, okay, this one is y over x to the power of 0. But this one still not, because you have x to the power 3 divided by 1. It's not y over x. So this is not a function of y over x. So it's not a homogeneous equation. That's the way to find. I mean, first of all, we got to define whether it is a homogeneous equation.